Well, thank you all for coming for this last session. My name is Kees Moeilijker. I'm a past winner. I won the Ig Nobel Prize in 2003 for discovering homosexual necrophilia in the mallard duck. Yeah. But that's not why I'm here now. I'm here moderating these three gentlemen. They are winners of the 2024 Ig Nobel Prize. And for those of you who just walked in thinking what's happening here, let me explain that 2 days ago here in Cambridge, Massachusetts, at the Massachusetts Institute of Technology, the annual Ig Nobel Prize ceremony took place. And this ceremony honors anybody, scientists, discoverers, or ordinary people who did something that first make people laugh and then make them think. And this all started here at MIT in 1991. So it's the 34th time it's been organized. And we always have, the ceremony is open to the public if you buy tickets, and here it's free. And here the winners have a little bit more time to explain what they did and why. And what we're going to do here now is that we are speaking with three winners, and I will introduce them briefly, and they can ask each other questions. And that's really interesting because they're very interesting people. So here we have three winners. On the far left, yes, there is the winner of the Physiology Prize, Ryo Okabe.
Hi. Everyone.
And Ryo with his team, which I'm not going to mention all because, you know, Japanese names are kind of difficult to pronounce. They won their prize for discovering that many mammals are capable of breathing through their anus. Okay. In the middle, we have the Medicine Prize winner, Lieven Schenk, who with his team demonstrated that fake medicine that causes painful side effects can be more effective than fake medicine that does not cause painful side effects. Applause to Lieven. And next to me is the Botany Prize winner, Felipe Yamashita. And he got this prize together with Jacob White for finding evidence that some real plants imitate the shapes of neighboring artificial plastic plants. And before we start asking questions to each other, here's an opportunity for each of you to explain what you did in 1 minute, exactly 1 minute. So please, Professor Okabe, can you start your 1 minute?
Okay, I'm Ryo Okabe from Japan. Thank you so much. And I'll explain my research on some aquatic creatures such as roach. It's a roach. Can take in oxygen from their intestines. So our question is whether mammals can also take in oxygen from their gut. As it turns out, pigs, rats, and mice can all take in oxygen from their intestine. And our method can ameliorate severe respiratory failure. In conclusion, mammalian enteral ventilation ameliorates respiratory failure. And the study is in clinical trials. Thanks so much.
And the next speaker is Lieven Schenk. Can you explain in 1 minute what you did and why?
Yes. So we wanted to see if and how side effects could also help with your treatments. And this sounds like a very counterintuitive idea, of course, because side effects are generally bad. But depending on the context and on the seriousness of the side effect and so, this is actually what we would expect based on previous research on placebo effects, that this could be like a cue that boosts your expectation, and then by boosting your expectation, increase your non-pharmacological component of the treatment, like the placebo effect. And we did this in a pain model, and based on that, we would expect that this activates your endogenous, so your internal descending pain modulatory system, that then in turn lead to less pain. Thank you.
Okay, Felipe, your 1 minute.
Okay, so there is a plant in Chile and Argentina, and this plant is capable to mimicking leaves of other plants. So there was a study 10 years ago, and give a hypothesis that this plant could mimic with a volatile substance from the host plant to the name of the plant is Bocchilla trifoliolata. So the Bocchilla captured this volatile substance, or they captured some genes from the host plant. And we didn't really agree with this hypothesis, so we said maybe this plant have some eye, some vision. So we place a plastic leaf close to this plant, and they start to copy this leaf shape. So we have a new hypothesis. It's not our hypothesis. Is this theory was from 1905 from Haberland. So he said there's a ocelli theory. The plant can have some eye. So this is our theory from this plant.
Okay, thank you. Well, Rio, do you have a question for any of your colleagues?
Okay, I have a question about the capsaicin. And is it a possibility that capsaicin has anesthetic property or effect?
So we what we actually used as a placebo with side effect was a nasal spray with a very small amount of capsaicin, which is people who know what it is start laughing, which is actually chili pepper, right? So now I have to make a slight correction. So our side effects weren't actually designed to be painful, although this sounds very painful. But if you use a very, very small dose, you just cause some strange feeling in the nose, a little bit uncomfortable and so on. And that was what we wanted to go for. So for it actually to be, so there are like capsaicin treatments for pain, but first of all, you would have to use them on the location where you actually want to treat the pain. And second, our dosage was so low that we wouldn't expect any pain relieving effect from the capsaicin alone.
Okay, thank you. And Lieven, do you have a question for one of your fellow winners?
Yes, so I was wondering, why did you use a plastic plant and not just another plant and looked if it mimics the other plant?
We just use a plastic plant because in nature this plant can mimic more than one different species. So if we use another live plant, they could argue again, okay, the volatile substance is changing the leaf format, or the gene, there's some gene transfer from one plant to another plant. So for avoiding these two hypotheses, to create a new other one, we need to get a model with not transmitting any chemical or any genes. So we use the plastic plant.
That makes a lot of sense.
And did you, where did you get the plants? From like the supermarket or?
Yeah, a normal shop. The other author, Jacob, he got in a regular shop here in the United States, And then after that, we got these plants also in Germany. Then we are doing more and more experiments.
Because the worm guys, they got their worms from a pet shop, from an aquarium shop. So
Yeah, it was a regular
Regular.
plant shop that you can buy in
Okay.
any store like that.
okay, well, good, thank you. I have a question for Rio.
Yeah.
How did you come up with the idea of studying this? Was it related to the COVID period?
After experiencing new COVID infection and lung transplantation, because I was a surgeon, and we thought we need new respiratory devices or systems. So we compared how plants and animals can take in oxygen, and started the experiment after studying the other creature's respiratory system, and thinking about it could be applied clinically.
So it can be that in the next pandemic, that those people who are suffering from lung conditions, that the actual treatment will be through the anus.
I hope so, but considering the only small creatures in nature can take in oxygen, so the good indication for human would be newborns, and I think the neonatal asphyxia is a good example of what the disease.
Okay. And did you already study this in humans, the treatment?
Yes, unfortunately. It's a joke. And yes, on phase 1 in clinical trials, and the young healthy man uses enema with perfluorocarbon, which is oxygen soluble, very oxygen soluble, and clinical trials have begun.
Okay. Do you want to respond on that, Lieven?
No, I just wanted to ask, how did you recruit the people for this study?
Well, I hope I confirm the safety and the effectiveness. That's it.
Okay. Good. Well, I hope there were volunteers.
Yeah. Thank you.
Yeah.
No, it's sometimes not always easy to find people participating in the experiments, right? So I thought it's probably you had to like a little bit more of a difficulty than we do usually. But
Yeah.
Something about the way you were describing that made me think of a cartoon character named Donald Duck. Do you know Donald Duck? Okay. What you discovered, does that apply to ducks? And does it apply to people named Donald?
Yeah, it's a little bit difficult question for me.
It's a difficult question, yes.
Yeah,
But,
yeah.
but does it work? Does it work in birds too? Do you think?
Birds, sorry?
Does your treatment also work in birds?
Birds?
Yeah.
No.
No, eh?
Mm.
Different system.
Yeah,
Okay.
different system. I think so.
Lieven, are you aware of the of an Ig Nobel Prize winner from several years ago called Dan Ariely, who discovered that expensive fake medicine work better than cheap fake medicine? Did you take this into account in your studies?
Yeah, so I'm aware of that research, and I can say this effect has been replicated multiple times now, so it's a true effect. Yeah, so I think with placebo effects, it's important to note, and that's a common misconception, is that placebo effects are always present during every treatment encounter that you have, may it be with a fake medicine or with a real medicine. And so, yes, it seems to be that if you give someone a medicine and say this is very expensive, that this may cause a slightly higher placebo effect than if you say this is like the over-the-counter medication that everyone can get for 50 cents.
Interesting. Yeah. Felipe, the big question that remains, of course, from your work is how does it work? How do the plants, how do they do it? Do you have plans for a follow-up study? And what's the focus of that?
Yeah, so the next step, this research was from 2021. This paper was published 2021. And after that, we got some more plants and we start another experiments. And this one we use a plastic leaf, so it's a 3D model, right? And we receive some critics say, oh, it's just because of the shade, they can make some shade on the leaf and they can change the leaf pattern, leaf format because of this. Then we use, this data is not published yet, but we use a two-dimensional model, and they also copy this two-dimensional model. So it's definitely not the shade, or mechanical contact, because the Bokila could grow over the plastic leaf and touch the leaf and have some mechanical contact. But with the two-dimensional, they cannot have this contact. So.
And is this something that people can do at home, like experimenting like this? Or are there other plant species that do the same trick?
Yeah, it's possible to do at home, but now for this other experiment we have like 70 plants, so you have a room for 70 plants, give some space. Yeah, for sure you can do at home.
So we can just go to like the flower shop, buy a plant, go to the next shop, buy an artificial plant and start doing science at home.
Yeah, you can do it. Darwin did a lot of experiments at home.
That's true, yeah.
Yeah.
Okay, but you have to have the right plants, of course.
Yeah.
Okay, right. Good. Any questions from the audience, please?
So where does this mimicking stop if we put your plant next to one of the bananas there?
We never try to use any other thing besides leaves, but we already received some questions. If we use different color, instead of green, use yellow as a banana. But I have no idea yet, but we didn't choose this option, we just use regular leaves.
My question is also to Felipe. So the hypothesis that plants would have vision doesn't sound so likely, but you could test it by just putting a screen between the plastic plant and the mimicking plant. Did you try that?
No, we didn't try a screen because you need to run this experiment for. They start to copying after 2 weeks, but we run the experiment for a month. After 2 weeks, they start to copy already. But for the screen, I think also could be a possibility, but we choose a cheaper option, like printing leaves on paper.
Okay.
Also, briefly on the plants, there's like a pretty broad shape space that they can explore, right? If you take like a vine or something, how far does the mimicry extend? We talk about leaves, but is it also in things like shaping of like stalks, etc.?
Yeah, maybe they can copy, but what I think they're gonna copy, just my belief, I don't have any data on that, but they were just copying some green leaf because most of the greens are green, so probably are gonna have some better chance to get some copy on the green leaves, or maybe other like on the autumn do you have other colors, maybe these colors also is going to be good.
I have two quick questions. One's for the plants again, which is, do you think you could like make like a plastic plant that has like some crazy leaf that's never been seen before and get the plant to copy that? And then for the breathing through the back end, how long do you think like a mouse could live just doing that? Like if it's, you know, is like, I don't know, did you test this at all? Maybe it'd be cruel, but how long could they like breathe with that?
Yeah, mouse could be about live 1 to 2 hours under the severe condition. But I think it is a special condition is needed because we can't we didn't experiment, but some hypo metabolism state, and it's a bit. It needs a good, healthy lung condition. So it's some kind of a special condition to live.
And answer his question. Yes, we use another different shape. So for doing this research that we did last year, we searched some from specific different shape that is not in contact with the same plant in South America. So we choose a plant, we choose a one plant close by, but we choose another leaf format for a plant from like Asia. Totally specific, unique leaf shape, but I'm not saying because we didn't publish this paper yet, but yeah, but they copy totally different leaf shapes.
Hi, Felipe. I have a question, maybe not so much on the eye of the plant, but of maybe how a plant make a choice. So let's say you have the plastic plant next to the plant, but you have also a similar plant next to the plant on the other side. Yeah, what happens then? And is there maybe a threshold, like if there are two plants that are plastic and one that is similar, then it goes this way, or yeah?
So these plants is a liana, and they are growing in the forest. Close to a lot of different species. And what this research from 2014 find out, one individual from Boquilla plant, this Boquilla is the name of the plant that mimics, so they copy a lot of different shape. So they are going just to changing, not combining, but some leaf from one branch is copying one species, leaf for the other branch a little bit above, copy other plant species, so they are just copying. Everything is going around.
Yeah, I have a question for Lieven. So you mentioned that painful side effects work for fake medicine, so why would you call it fake medicine still? Because it seems to work.
Well, I think that's a very good question, but it's so we would call it a real medicine if there is an actual pharmacological effect, because you can, like, if you can create an expectation that something works, nearly everything can help in some way for specific conditions. For example, with pain, expectation effects, placebo effects actually work pretty well, and it doesn't have to be like a medicine. It's okay if it's just like, oh, I hurt my knee, I'll sing you a song or so. This also causes your for your child, for example, that it has, oh, okay, I will be fine, and it activates your own descending modulatory system. So, but I would still call it fake medicine or a placebo because it doesn't have a pharmacological effect.
Thank you. I have a question about the prize in medicine. Do your findings suggest that medicine really is better for you if it tastes bad?
To a certain degree, yes. Yeah, so our work was, of course, focused on side effects. We know that there are many different factors that can influence your expectations, and we just wanted to see how this relates to side effects, because it's very it hasn't really been studied, and it was something that made sense, so we wanted to try it.
Yeah, I also had a question for the chili pepper guy. So other people have described, so you showed how physical pain can benefit people in believing in placebos, and someone else mentioned the expense of medicines can also encourage this effect in people. So it seems like pain, either financial or physical, could be beneficial. Are there any other hardships that people with placebos can benefit from?
So it doesn't necessarily have to be something bad. As long as it boosts your expectation, it can help you. And also, I just want to mention it again, our side effect wasn't actually painful, it just sounds very painful. It was just a little bit uncomfortable. It was just something to really make them notice that something is going on in the nose. But if it would be actually painful, the effect probably wouldn't work. Or you would get some other pain modulatory effects that we were actually not interested in.
Thanks. Lieven, did you try your medicine on yourself?
Yeah, that's a good question. So initially, when we tried to create this, we were like, how are we going to do this? Yeah, let's try this with the capsaicin nasal spray. So I asked the pharmacy to create something, and I tried it on myself. Of course, I always do that before I do something to participants. And I have to say, the first thing I did was reduce the concentration by by a factor of 100.
So what's the peak level of uncomfortable? What is there a level that's best for the pain?
So you mean how uncomfortable has the side effect to be actually useful? That's actually a very good question, and I can't give you a definitive answer because we just tested like one specific level of uncomfortableness. But the expectation or the hypothesis or the idea is that as it has to be like a mild side effect that you notice and that is like clearly perceptible and associated with the medication. But if it's going too far into uncomfortableness or it's getting harmful or so, then it's unlikely that it actually will have any beneficial effect, and the negative effect would outweigh the positive effect. So it's only good if it's like, medicine tastes bitter or something like that.
I can ask this because Lieven's my roommate. How does it compare to like a pleasurable side effect? Like, wouldn't you want to do that?
That could work too, because it's just about increasing your expectation that something is going on, that something is working, right? So a pleasurable side effect could work too. Unfortunately, in medicine, it's quite uncommon to have pleasurable side effects. It's right. So, so we investigated what is more likely to happen in clinical practice.
Both for the breathing through the anus and the plant modifying, copying other plants' leaves. Are they supposed to have some evolutionary advantage, that ability to do those things? Or are they just accidental, especially for the anus one?
Oh, it's a good question, and it's so difficult to answer. But I think it's evolutionary found, I think.
And for the plants, this could have an evolutionary effect. So the hypothesis why they do that these plants change the leaf format is to get eaten less from herbivorous or predators. So if they get eaten less, they could like propagate and leave more. But this, if they copy and they are eating less, so this is beneficial for them.
So in terms of just to briefly elaborate, a number of different animals do this. Freshwater loaches do this. Certain types of Australian turtles do this, and catfish do this. And those have evolved in pretty different environments. For the loaches, for example, in these mud ponds, they enter these oxygen-deficient environments. So it seems to be a feature that is evolutionarily accessible, maybe through multiple paths, so independently evolved. In mammals, it's not intuitively, it doesn't seem like there's active selection, but based on general properties of the gut, given a certain concentration of oxygen, if the concentration gradient's high enough, it just works. So hopefully that elaborates a little.
For the capsaicin benefits, did you observe any differences between sex or ages?
No, we didn't really observe any differences between different sexes or ages.
Okay, well, I think this is a time to stop. Well, thank you all. Thank you, our 3 winners. Applause for them. And thank you all for coming to this session in the afternoon. And I also want to express my gratitude to the MIT Museum that hosted this event. It's very nice to be here. It's such a beautiful new museum, and we hope to come back here soon. Thank you.